Hi everyone, this will be your video for solving systems, but this one's specifically for the substitution method. Alright, so here's our key concept for the substitution method. So our first step would be to solve one equation for one of the variables. So in other terms, what we can think of, this is isolating. I'm going to isolate a variable. So we want to get it by itself. You want it to either say x equals and have a whole expression on the other side, like this, maybe something that will end up looking like this, okay? Or it could be any other variable, but you're isolating a variable. Once you do that, you can substitute it into the other equation. So that's the big thing here. Do not plug it right back into the equation you're working on. It's the other equation. And that's going to give you a new equation with just one variable. So you might just see only y's, and that's what you want. Once you have that, you can solve that equation. Once you have that, now you have, maybe it'll say x equals 2, right? So you have some sort of solution, but it's not the whole solution. You're going to substitute it to solve for the other variable. So this can be into either equation. This is called back substitution. We're going to talk about this a lot. Okay, so back substitution means I have a solution. I'm going to go back to my problem. I'm going to work my way back through it, and I'm going to find my whole solution. So we do need to figure out what is a solution, and we have already talked about this in our graphing method, but in case you forgot, your solution of a system will be the coordinate pair where the lines intersect. Okay, so we did talk about that before, but in case you forgot, so it's a little note for yourself, maybe copy that down if you did forget. So your solution will always look like a point that's x, y. All right. Here is our first example. So we're going to use substitution. We know that because the directions tell us, but one of the tips that you'll see on the next slide is that if you have a variable that does not have a coefficient, or the coefficient is just a -1, that's a good indication that substitution will work for you. So we're going to rearrange this second equation. So we're going to rearrange to isolate y. All right, so we have 5x minus y equals 14. So we're going to get y by itself. I'm going to subtract the 5x. So I have negative y equals 14 minus 5x. And then I just need to make that a positive y. So I'm going to divide by -1. And I need to make sure I divide every single term by -1. I have y equals negative 14 plus 5x. All right, so this is good. So we know what y equals in terms of x. So when I say that, it means I have a y equals and then something with a variable of x. So we're going to replace that in to our other equation. That's technically like our step 2. Okay, this was our step 1, if you're keeping track there. Okay, so step 2, we're going to replace. Substitute, right? It's the name of the method here. So we have 2x plus 3y equals 9. And we're going to replace that y with what it equals. So we have 2x plus 3, and that's negative 14 plus 5x equals 9. All right, so now we only have one variable. That means we're good to go to solve for x. We have 2x. So we have 3 times negative 14. That's going to give us negative 42. I'll make that a minus sign. And then we have 3 times 5x. So you just make sure you distribute to both. So we did our 3 times negative 14, we got our negative 42. And then we have 3 times 5x, we get 15x. All right, so some basic algebra skills, combine your like terms. So we have 17x minus 42 equals 9. We're going to add 42 and 9. So we have 17x equals 51. And when we divide that by 17, we get 3. So our x value of our solution is 3. This is only part of our solution. Okay, you're not done yet. We still need to figure out what y equals. So we need our step 3, and our step 3 was that back substitution step, right? So we know what x equals, now we just need to figure out what y equals. You can take whatever equation you like. Personally, I would prefer this one right here because it already says y is going to equal whatever this mess is. So we have negative 14 plus 5x. I know x is 3, so I have y equals negative 14 plus 5. I'm going to replace it with 3. So y equals negative 14 plus 15. You can see where we're going here. So y equals 1. So this is also just part of our solution. This is not our solution yet. When you are finalizing your answer, your solution is a point, right? We talked about that before. We talked about it on the last slide. So your whole solution is going to be the point, the xy point, 3, 1. So if you were to graph these lines, that's the point where those two lines would intersect. Okay, so to wrap it up, here are some tips for using the substitution method. I do recommend pausing here and writing this down. So the first one that you remember is that we did figure out if substitution was going to be best. Determine if you can isolate one variable. If you can, substitution will be an easier route to take. Now, if you can't, avoid those fractions and decimals. Do not force the substitution method. You're going to learn so many other methods that you don't need to be working with a fraction or decimal, and we know that we don't really like them that much. So that's my second tip for you guys. If you have any questions, reach out. I'll be here for you, and I look forward to hearing from you guys next.